Hello everyone. Let's find the dimension for power. Power is equal to work over time, but work done is force times distance. So power can also be force times distance over time. But the dimension for force is m raised to the power of 1, L raised to the power of 1, and T raised to the power of minus 2 times the dimension for distance. Dimension for distance is L raised to the power of 1. The dimension for time is T raised to the power of 1. So this is dimension of force multiplied by the dimension of distance over time. This is also the definition of power. Multiplying this L raised to the power of 1 with this L raised to the power of 1, we have L raised to the power of 2. Therefore, this is going to become m raised to the power of 1, L raised to the power of 2, and T raised to the power of minus 2 all over T raised to the power of 1. If T raised to the power of 1 is coming up here, if you are dividing two same bases, you are going to be subtracting the power of the denominator from the power of the numerator. Minus 2 minus 1 gives minus 3. T becomes T raised to the power of minus 3. Therefore, the dimension for power is m raised to the power of 1, L raised to the power of 2, and T raised to the power of minus 3. Now let's move to momentum. Momentum is equal to mass times velocity. But velocity is displacement over time, so I can also write this equation to be mass times velocity is displacement over time, so it can also be like this. The dimension for mass is capital M multiplied by the dimension for displacement is length, which is L. The dimension for T is capital T. Therefore, the dimension is going to become m raised to the power of 1, L raised to the power of 1, and T, if T moves up, it's going to become T raised to the power of minus 1. And this is a dimension for momentum. How do we derive the dimension for impulse? Impulse, J, is equal to force times time, and the unit is Newton second. Force is mass times acceleration. Mass times acceleration multiplied by time. Impulse can also be mass times acceleration times time. Now, how do we find the dimension? What is the dimension for mass? Mass is capital M. Acceleration is m raised to the power of 0, L raised to the power of 1, and T raised to the power of minus 2. Multiplied by time, the dimension for time is capital T multiplied by T. And this is raised to the power of 1. This is raised to the power of 1. So how do we analyze this? M raised to the power of 1 multiplied by m raised to the power of 0. So I have 1 plus 0, which gives me 1. So this is m raised to the power of 1. I have just one L raised to the power of 1. I have T and T. This T is raised to the power of minus 2, and this T is raised to the power of 1. If you are multiplying two same bases, you had their powers, and this is minus 2 plus 1, which gives minus 1. So T becomes minus 1. Therefore, the dimension for impulse is m raised to the power of 1, L raised to the power of 1, and T raised to the power of minus 1. If you compare the dimension for momentum and the dimension for impulse, you see they are the same. Even their units are also the same. They have things in common. The dimension of volume is one of the easiest to derive. Volume is length times breadth times height. The dimension for length is capital L. The dimension for breadth is also capital L, and the dimension for height is capital L. Why? Because the three quantities are all measurement of lengths. I have L raised to the power of 3. This is 1, 1, 1. Multiplying those three quantities, the power is going to be addition. 1 plus 1 plus 1. That is L raised to the power of 3. So the dimension for volume is L raised to the power of 3. Compare the dimension for volume with the unit of volume. The unit of volume is cube meter, while the dimension is L raised to the power of 3. This is to say that the dimensions and units are totally two different things. Since there is no m and there is no t here, I can also write the dimension of volume to become m raised to the power of 0, L raised to the power of 3, there is no t, so I can make the t to become t raised to the power of 0. You can write it this way, you can also write it this way. Moving to the next on the list, which is density. Density is mass over volume. The dimension for mass is capital M. The dimension for volume, we just found volume, is L raised to the power of 3. This means that this is raised to the power of 1. So bringing this up here, it becomes m raised to the power of 1 and L raised to the power of minus 3. I can also write it this way. If you notice this, you can see there is no t, so you can also write it in this format. M raised to the power of 1, L raised to the power of minus 3, and t raised to the power of 0, because t is independent of no physical quantity. Let's derive the dimension for frequency. Frequency is equal to 1 over t. If I want to write the dimension for frequency, this is going to be 1 over dimension for time is t, capital T. Let me write it completely. 1 over time, or 1 over period. So this becomes t raised to the power of minus 1. Mechanical quantities can be expressed in terms of 3 fundamental quantities, which are m, l, t. Since there is no m and there is no l, I can make the m to become to the power of 0, l to the power of 0, and then bring the t is raised to the power of minus 1. And this is the dimension for frequency.